Hi, sir.
Hi friends, am I audible?
Yes, sir, you're audible.
Yeah,
Uh,
Kavya.
yes, sir, I have it out. Can I share my screen and show you?
Yes, but these things we can take up at the end of the class. Okay, for now you can share for today. Okay.
Okay.
Yeah, shall I make you as the co-host? I should make it.
Yeah.
Wait a moment. Yeah, I made you as a host. Please share your screen.
Okay, sir.
So,
So, sir, this is how this is my instance. If I go to my,
on Saturday, was that you who have shared the screen and shown me?
yes, sir. Yeah.
Okay. So you are able to connect to the instance now. Okay.
Yes, yeah. So I'll just show you. I am uh, putting this Python.
Good. Yes.
So
Yeah,
that,
it's pulled.
yeah. So now if I see my Docker images, it's there in the Docker images, right?
Yes,
So
it is there.
if I want to run this, that is not happening. That's the problem. Like, so, uh, okay,
Uh,
it's saying it's already in use, right?
yeah. Run Docker PS.
Yeah. So if I do this, it's showing as exited. I don't understand why it is.
Okay. You will understand going forward. Okay.
Uh,
Okay.
okay.
That is expected thing only. You will understand. Okay. That
But
topic we did not cover it.
I did not do anything. Even if I do Docker PS, I should get it right. I'm not getting it under this any no information.
Because that is in exited state. So that will be shown in the Docker PS-A command. Okay,
Mm-hmm.
so in Docker PS, what containers will be shown? The containers which are up. That means which are running currently. Those things will be shown in Docker PS command. And the containers which are running as well as exited, all the containers will be shown in PS-A command. You got my point, right? So
Yes,
this
yes.
thing, you are saying
Uh,
that you ran the container and you named it as C1, but it was exiting, right?
yes, yes.
Okay, I will let you know that you will
Okay.
understand. Then why you are taking Python too early? Is there any work with Python for you now?
No, it's not that. I mean, randomly I was selecting, but I'm well versed
Okay,
with Python, so I just.
okay. I will tell you. I will tell you why that was being exited as soon as it came into running state. Okay, don't
Okay,
worry.
sir.
I will take up
Yeah.
that.
Okay, sir. Thank you.
Okay. When I explain about the Ubuntu container, you will understand that.
Okay, sir. Yeah.
Okay. Yeah, friends, we are discussing about various commands that are associated with Docker. When we install Docker, by default, Docker CLI is installed. And by design, Docker is connected with the Docker public registry, that is Docker Hub. From there, the Docker will be pulling the images. We will also see how to create private container registries and how to deal with them going forward. Okay, so now let's understand few more commands that are associated with the Docker. Okay, So let's go to the document. Okay, so we have seen D, we have seen P, capital P we have seen, and IT, exec IT we have seen. Okay, I will tell you this as well again. So name, these things we will be using frequently, and we have to understand, E we have to understand, other things, lot of things are there that you will understand. Pull command is used to pull the image from the Docker hub to the Docker host. Okay, this is a command to list out the images. This is the command to download the image. This command, again the same command here. What we are doing, you know that we are performing port mapping. This is the Docker host port. This is the container port. Okay, so now Docker exec ID, this command, what it does is it will take us into the container terminal so that we can execute the command there. Okay, this is to stop the container, this is to remove the container, whether it is running or stopped. Then this we have seen, this also we have seen. Okay, now let's come here. Okay, so hopefully Kavya's problem will be resolved here itself. Okay, so now till now we have dealt with the containers where some application is running in them. For example, we have run a container from Tom image. So in that container, what was running? Tomcat server was running. Some process is running inside the container. Nginx container we have created. In Nginx container, what was running? Nginx server was running. Okay, so that's why when we create a container or when we run a container from the image, immediately the container is running with the application. That means inside the container application. For example, Jenkins container we are running. That means Jenkins server is running inside the container. Nginx container we are running. That means Nginx server is running inside Nginx container. Likewise, Tomcat was running in the Tomcat container. Now, what I will do is I will show you the image here. Okay, so here we have installed Docker, and in that a container is running. Here 3 containers were running. And in this, let's suppose that this application A is Jenkins. Here the application B is Nginx. Here application C is Tomcat. So in these containers, a process is running, an application is running. So that's why the container will be up in the state when we run the container from the image. Okay. Sorry guys. But now I will take containers which do not run any application. They are just operating system containers. Okay, for example, Ubuntu. Ubuntu is just a container, it's a virtual machine. That container we will run. But we are not running any application in that. Okay, pure Ubuntu operating system we want to run in the form of a container. Likewise, we want to run CentOS in the form of a container. Likewise, we will run Python container. In Python container, what will be there? Python is installed. Python terminal is installed. That's it. There is no application running inside that. For example, if you write some py file and if you execute that, that means some Python application will be running. But here we are just trying to run a container which is having Python environment. Okay, so that means we are having an environment with the Python. Okay, for that, what will happen? Let's see. Okay, so now I want to create Ubuntu container. For that, the command is docker run. Generally, it is container run. Okay, container run, but that's fine. We can write simply run. What's the name of the container? Let's run it as my Ubuntu. Okay, So at the end, we have to provide what? Image name. Okay. So this is the thing. Let's hit enter because that image is not already downloaded into our local machine. So that means in the host machine, it is pulling from the Docker hub. If you see that container is not listed here, Kavya, this is the problem you are facing in case of Python. Am I right?
Yeah.
Okay. Now exactly, if you see that is their exit state. This is what exactly you are facing.
Yes, sir.
Okay, why this is happening? I will tell you now. We have to explain. So when we are running the container, using this image, this is just an operating system based image. There is no application running inside this. For example, in case of Jenkins application is up. Jenkins application is installed and we made it to run. How we made it to run, we will learn during the session where we will explain how to create our own Docker images. There we will have entry point and CMD. There you will understand. Okay, but here we are trying to create Ubuntu environment, and this is just an operating system. We are not running any application inside that. Once we create the container, we can run the application inside that. That is secondary thing that we will learn in Docker file. Okay, so now what I will do is Docker start. I'm starting this container again. Okay, so now also what happened? It exited. Why it got exited? Container is started, friends. Container started, but immediately after container is started, it is exited because there is no application running inside that. Okay, so now how to, if there is no application running and if it is exiting, then what's the use of creating the container, right? We are running the container from that image like Ubuntu, and the container is exiting. Then what's the point of having such container? Okay, now we will learn it. Let's remove it. Docker rm my Ubuntu. So whenever we are creating operating system based containers, okay, so in that case, what is happening is the container will come into running state, and because there is no application running inside it, it will be exited immediately. So why we need to create operating system based image first? To have some Ubuntu environment. For example, let's say we want to, this is Ubuntu machine, right? So the Docker host is Ubuntu, Ubuntu 18 to be specific, that we have created using AWS EC2 service. Now I want to have CentOS. I want to have CentOS kind of distribution. Okay, so the Docker is running in Ubuntu 18, and just now we have created Ubuntu, and I want to end because there is no process running inside it. The container was exited, but this time I want to have CentOS environment in the same machine. Remember, our host machine is Ubuntu, but I want to have CentOS environment. Is it possible? Yes. How it is possible? My CentOS. Then here we have to give the image name. What's the image for CentOS operating system? So if you go and search in Docker Hub, so the name of that is CentOS itself. And this will also be exited immediately after its creation. Let's check it. Docker PS, see what happened. The container got exited. See, if you see from Ubuntu to CentOS, this Ubuntu operating system image was about 78 MB in size. The CentOS is somewhat somewhat heavier than the Ubuntu. Relatively, I am speaking. Okay, 231 MB. That's fine. So when we run the container, in this case also container was exited. Docker ps -a. So the container is in exit state. Now let's remove it. Okay. Now how to interact with this? How to interact with this? What's the point of having the container when they are exiting as soon as they are created? Okay. So why? So what's the use of them is Docker run -name my CentOS. Because these are operating system based images, we have to interact with the shell of the container. Okay, so Docker run -name my CentOS -it. Then what's the image name? CentOS. So we have to give -it for operating system based containers. Okay, so operating system based. Now you may be getting some doubts, sir. Python is not an operating system. Yes, it's not an operating system, but that Python software was installed in some Ubuntu operating system. Okay, so that's it. There is no Python application is running. Only Python software is installed in some Linux container. That's what it is. We will learn, of course, during Docker file, you will understand this more clearly. So if you don't give -it, what will happen? Container will be exited, but I want to run. I want to interact with it. For that, we need to give -it. See what happened now? The control came into the container terminal from the host. Now, here, see, we are inside what? CentOS. We are inside CentOS operating system, which is running on top of this Ubuntu. Okay, so this is CentOS. Let's suppose that. Okay, actually we have Ubuntu operating system, but we have the need for, we are in need of having some CentOS environments. So that's why with the concept of containers, we are able to bring up the CentOS environment with one command, that too very fast. Okay, so now let's create some file. Okay, so va file1.txt. So va editor is already installed in this. So that's why it is somewhat heavier. If you take Ubuntu image, their va editor is not came with the default, not came default. We have to install va editor there. We have installed it also in the earlier class. So now, hi friends, this is first file created inside the CentOS container. Okay, this we are running. Let's cat it. This is the content that we are running. Okay. Okay, clear command is not there here in the why clear. Okay, clear is not available in this. That's fine. Now, what I want to do is I want to exit from this. I have some work to do in this. Okay, so that is done. That is done. Okay, now let's keep it for. Okay, some split command is running inside. That's fine. Okay, so now what I want to do is I want to go to the host terminal from the container. Okay, for that we have to use control PQ simultaneously. Press control PQ. Okay, if you do that, the control will come to the host. Okay, now let's execute Docker ps. Now what is happening? The CentOS is now running because we interacted with it. Okay, so now it is running. We have started some process in that. Okay, so now, okay, that's running. Now, how to go inside it again? Docker exec it into my CentOS. Okay, To interact with it, with the container, we have to use exec IT when the container was running. When, if you want to interact with the container, when you are creating it, then we have to use just -it. Okay, in the Docker run command. Okay, now here we have to provide the shell. Okay, bash. At the end, we have to provide the container shell. Okay, like this, we have to create. Okay, and see the file is there. Okay, we are able to see that file. This is one kind of operating system we are in. Okay, what's the command sent to us to clear the screen? Clear only, right? But why it's not shown? Okay, anyway, so I'm not worried about that. Okay, so now let's use PQ, control PQ again. Okay, control PQ again. Docker PS. Okay, so the bin bash, when we are using bin means by default it will take this path. This is the executable path of the bash. So that command was executed. That's why it is showing there. Now, if I want to interact with it again, we can do it. We have to provide the shell at the end, then create one more file, file2.txt. Okay, this is second file. Save it, :wq. You must be knowing that file2.txt. That's fine. Okay. Now let's use exit. Let's use exit. Exit, what it does in this case also, we came to the terminal of the host. When we have applied exit, earlier also in case of control PQ, the same thing happened. The control exited from the container and it came to the host in case of control PQ as well. But in case of exit also same thing happened. Okay, now see. Okay, so same thing will happen. Control PQ and exit will do the same thing. But sometimes if you use exit, what will happen is it will also exit from the container and container will be exit instead. So I always recommend you to use control PQ to exit from the container terminal, but not the container. Okay, so that is now I will create Ubuntu. Okay, what will happen if I do this? Container will be exited. It will be in exited state. Okay, that is in exited state. So now what I will do is I will remove it. Okay, I will run it again. Now I will use -it. Okay, we are into the container. Now let's use exit here. I use exit here. See what happened when we have used exit in case of CentOS. We exited from the container terminal, but not the container. But in case of Ubuntu image, if I apply exit, what happened? The container got exited. You see the container got exited. Okay, so that's why. Now what I will do is I will remove that. Okay, and I will run that again. Now this time I will use control PQ. I have used control PQ simultaneously. Now let's see what happened in this case. Ubuntu container is running. Okay, so some minor difference between exit and control PQ. And what I want to tell here is I always recommend you to use control PQ Okay, so that's the reason I always used to use control. I always recommend you to use control PQ to exit from the container terminal, but not the container. That is one thing. Now let's come to the Kavya's question. Docker run -n equals to Python environment. Okay, let's name it as Python environment. This is the name. So if you see this, see this Python image took somewhat longer time than the Ubuntu and CentOS image. So once this is completed, we can see its size also. Let it complete. So here, if you see, what's the size of Python? It is about 925 MB inside. Why this is heavier than these two? Because Python software is installed in some Linux container. Okay, Python software was installed in some Linux container. Of course, we will understand the term when we go to the Docker file and when we create our own images. There you will understand. Okay, so in general terms, you don't need to have any higher thinking here. Just this is just base images, and this Python is installed in some container, and that's why its size is relatively higher. And if you take Ubuntu, and in Ubuntu, VAEditor is not installed by default. But if you take CentOS, VAEditor and other kind of things are installed. So that's why it is somewhat higher in size than the base Ubuntu. And Python is higher in size than these two because Python is some big application than the things that were there in these two things. Okay, so that is the Python. So now I have Python image. Okay, now let's run container from it. Okay, I think we have created it. Okay, Docker PS A. See, Python is exited. Why? Python software, we have created a container which is having Python software. Okay, now there is no Python application is running. So that's why when the container is came into running state, immediately it will be exited. Okay, now I want to go inside the Python container. How to do that? For that, okay, so Docker rm Python env. So if you observe Docker run, and friends, we have different kinds of Pythons, right? Python 2, Python 3. Okay, so what kind of Python is running inside this? Okay, so I want to interact with this container. Okay, so my system, so that means this machine is now running so very slow because so we are this Python application may consume more RAM and memory. So IT, okay. So let's give the image name at the end. So now let's name it as Python software. Okay. So when we are interacting with it, see what happened. We are into the Python environment. Kavya, is your doubt clear now?
Yes, sir, it is.
It's clear, right? So now print hello. Okay, this Python environment. Okay, okay, we quit from it. See, it was exited. Yes, -a. Now let's start Python start Okay, Python got started. Let's interact with it. Exec IT Python soft is the container name. Okay, but we have to provide what? So we are into the container terminal now. We are into the container terminal. So here we have to observe one thing is when we are giving this means this is a command. This command will be executed inside the container. Okay, now I will tell you one thing. Now we are into the container, we are into the Python container, okay, but not Python terminal. Okay, now let's execute Python 3. See, Python 3 is started inside the container. We are into the Python container shell, then we have executed Python 3. Okay, so now we exited from the Python terminal and we are into the Python container. This is the container. Okay, so container nothing but what? It's a virtual machine. Now I want to exit from here itself. Control PQ we have to apply. So with that, what will happen? This is the thing. Now this time I want to directly run Python terminal. Docker exec IT Python soft Python 3. See, we are into directly. So this how I am providing, how it is running, we will understand during entry point and CMD instruction. Okay, so for time being, you have to remember that. So whatever the command we are giving at the end when we are using exec, so that will be executed inside the container. Okay, so this Python 3 will be executed where? It will be executed inside the container. Okay, this is how it is being executed. Okay, so then now let's exit from it. We exited from it. So I want to remove all these containers. I don't have any work in this. Okay, Docker RM. I want to forcibly remove all this. Now Docker PS AQ. Okay, it will remove all the containers. So there are no containers, but still images will be there. If I want to remove all the images, we have a command Docker system prone -a. Okay, it will ask for confirmation. Yes, what's the command? Docker system prone -a. It will remove all the Docker images. Okay, that's fine. So now our Docker host is clear. There is no container running inside it. Now let's move forward and understand. Okay, so this is something like a scenario, not a bigger one. Okay, so start Tomcat as a container and name it as web server. Okay, perform port mapping and run this container in detached mode. Start Tomcat as a container. To start Tomcat as a container, what we need to have? We need to have the Tomcat image. Okay, so that is Tommy. And to name it as web server, hyphen name web server, perform port mapping. This is how to perform port mapping. Okay, so this we have seen already. So start Jenkins as a container in detached mode. Name it as dev server, perform port mapping. So Docker run. As I said, these options can be interchanged. They can be anywhere. No need to be maintained in any order here. So I want to run the container in detached mode. I want to name that as dev server, and we are performing manual port mapping. This is the container port. This is the Docker host port. This is the official image name of Jenkins. Okay, this also we have already seen. This also start Jenkins as a container and name as app server and run this in detachment, perform automatic port mapping. Automatic port mapping means we have to use capital P. All these things we have seen. Now let me run it for you. See, Docker run, name of the container is this one. We want to perform automatic port mapping. That means we are not choosing the Docker host port explicitly. Okay, so -d stands for detached mode, and this is a container image. Now, if you see, so this will be running, and if we inspect Docker inspect app server, okay, so it got an IP address. Okay, now let's call it. And what is the port? Port we have to give. Okay, and this is internally we are accessing. We don't need to have the Docker host port. Directly we can run this with the container port, and the container port is 80. Even if you are not mentioning 80, by default it is assumed that it is 80. That you know, that is HTTP default port is 80. Whether you give 80 or not, by default it will be 80 only. Okay, and if you want to run this externally, that case what we need to do, we have to perform port mapping. In the automatic port mapping we have performed. So if you see, what's the port? 32768. 32768. Copy the public IP address and the public DNS name. 32768. Why it's not running? Oh, I think I did not choose the default security group. Let me allow the port. That port we have to allow. So for time being, let's allow all the traffic. Okay, that's fine. Okay, if you have the knowledge of AWS, that will take effect immediately. Okay, so this is interact with the container. We have to use Docker exec IT, and that way we have to interact. We have seen that. So this we have discussed. Now let's understand about E option. Okay, E option. So I want to run MySQL database inside a container. For that, what we need to have, we should have MySQL Docker image. And if you go to Docker Hub, there MySQL is the image name, and there are different tags for there. Here we are using tag file. And this tagging we will understand when we are using Docker build command to build the image from the container or from the Docker file. We can build the images from the running container, as well as we can build the images from the Docker file, which is a simple text file with some instructions, which we will learn. That is the heart of this entire Docker course. What is it? The Docker file. That is what we will be using mainly in real time. And these things also we will use, and that is very important to containerize our application. Okay, so now Docker run, we know this. We want to name that as MyDB. You can name anything. This is the container name. I'm naming this as MyDB. I want to run this in detached mode. And here -e, this E stands for environment. So that means we are passing environment variable to the MySQL database. And what's the environment variable? This is the variable name, and the value we are passing is Laxman. And this is the image we are using. Okay. So now let's execute this command. If you want to install MySQL database, how many steps you have to perform? Imagine. But here, because we have the ready-made MySQL Docker image, we can bring up the MySQL container within no time. Okay, so now let's use it. So this is the environment variable, okay, that we are passing to the container, the application, and the value we are giving is Laxman. So the password we are providing as Laxman. Because that MySQL :5 is not downloaded already, it will be pulled from the Docker Hub, and from that content will be created, and that content will be named as MyDB. Okay, so now let's interact with it. See, MySQL application is running in that. Okay, Docker exec IT. Okay, what's the container name? MyDB is the container, or else you can use the container ID as well. Use hash. Okay, we are into it. Not this. We have some commands, right? Okay, so we want to connect to the database. For that, MySQL -u username, user is by default user is root, and password. What's the password we have provided? We have provided Laxman as the password. Okay, so if you hit enter, and I'm providing Laxman here, I have typed Laxman here. See, we are successfully into the container. Okay, so this is, then let's show the list of databases. Show databases. This is the command. See, these are the databases we have. We want to connect to particular database, and you should be database admin. You may be understanding all those things. Okay, just we have created the database using the container, and the container image is MySQL. Now let's exit from it. Just type exit. That's it. I'm using Control PQ to exit from the container terminal. So the container is running. Okay. Now Docker stats is the command. Okay, it will show the memory and other parameters. Okay, so this is the uses of the memory. This much of memory is being used, and this much of CPU is being used by these two things. Okay, and this MySQL database consuming more CPU and memory than this. Okay, so you can read about this matrix if you want. I just have shown that command Docker stats. That means statistics. Okay, that is one thing. So till now we have seen individual containers in isolation, but in reality, let's suppose that we have some front-end application. Let's suppose that WordPress, we have database. Let's suppose that the database in our case is MySQL. And till now what we have done is we have created the, I think we haven't seen the WordPress, that's fine. We'll see. So we have created the, we will create the WordPress. This is the WordPress application. which will be running inside the container. And we have already seen how to create the database, that is MySQL database. You can create Postgre as well. Okay, so MySQL database we are creating here. In real time, why we will create MySQL database? Because some application needs it. So that means there should be a communication channel between two containers. We have to establish the network or the communication between two containers. Okay, so now how to do that? So we are trying to create multiple containers and establish connection between them. Then that setup is called as multi-container architecture. And there are two ways to do that. Of course, three ways. One is using link command, network command, and then if we have too many containers, we have the concept of Docker Compose to create multi-container architecture. So Docker Compose, in Docker Compose, what we will do is we will write Docker Compose file, which is an YAML file. In that YAML file, we will write the list of containers we want and the specifications of those containers. Okay, so first let's see the imperative way where we will use commands to connect two containers, and the Docker Compose will come under declarative approach where we will write YAML file. Okay, so now let's see the multi-container architecture using link, and after that we will use network, and after that we will learn Docker Compose. Okay, so link option. Let's go to the documentation. Link in Docker. So one thing, friends, I forgot to tell you. So it's a legacy command. Okay, Docker is recommending us to use a network today, but I will just I will tell you link how it will work. Then we will understand network. Okay, so network substituted link. Okay, and link is almost obsolete and we have to use network only, but link works. It's a legacy way of connecting the containers. Okay, I just okay. Okay, that's not needed at all. That's not at all needed here. Okay, so now what I will do is I'm trying to run a container. Docker run. I'm naming that as busybox1, and I want to interact with it, and the image name is busybox. Okay, and busybox is an operating system based container. That means there is no application running. It's a flavor of Linux, we can say, in container world. So now let's talk something about busybox. It's a lightweight Linux distribution. Okay, so if you see, busybox combines tiny versions of many common Unix utilities into a single small executable. Okay, so busybox is nothing but what? It's a Docker image, okay, based on Linux, and it combines tiny versions of many common Unix utilities. That means the VA editor, the ping, the curl, and these kind of things. Okay, so that's the thing. You can read more about it if you want. So busybox, as of now, you think like it's a Linux container with basic utilities. In conclusion, I can tell you. Okay, so now we are running that container and busybox image. If you want to read about it, you can go to Docker Hub, and there we will see the Docker Hub, and the image name for this is busybox. Okay, so busybox, click on it. 1 billion plus downloads, and you can read about it. See, it is very small in weight. It is between 1 and 5 MB only. Okay, then here we are into the, so this command we have run and we wanted to interact with it. So this is, now let's see, bi file 1.txt. Yes, BA is there in this. Okay, file 1. Let's go to insert mode here, click on it. File 1, something like that. Okay, so then that's fine. Now I want to exit from it. What I told, use Control PQ. Always this will be running. Now let's remove other two container for time being. This is one container. This is another container. And we have only one container running, that is busybox. Now, what I will do is I will run another container and I am naming that as busybox2. Okay, Docker run, name it as busybox2. Then let's not use this now. Forget about this command. Now, what we are doing, we are running the container that is called busybox2, and the image is busybox, and we want to interact with it. Hit enter. Okay, we are into busybox2 container. Control PQ, Docker PS-A. So we have two containers called busybox1 and busybox2. And if you inspect Docker inspect busybox1, and I want to grab paper IPv4, no such object. Busybox. Yes, spelling is wrong. Sorry, what I'm doing here. Okay, I think I have grabbed it with wrong thing. So busybox1 IP address is this one. Let's check busybox2. Busybox2 IP address is okay. This is the busybox2 IP address. Okay, so now what I will do is I will go inside the busybox2 and ping busybox1. Ping is used to check whether the two containers are communicating or not. Okay, so for that, what I will do is I will go inside busybox2 and ping busybox1. Busybox2 bash. So In BusyBox, bash is not available. Let's try shell. Yes, it is available. Shell is available. Okay. Then ping BusyBox1. Okay, let's ping it with BusyBox1 host name, the container name. Host name in the sense container name. And see what will happen here. Copy it. Why it's not being pasted? BusyBox1. BusyBox1. See what happens? Ping bad address BusyBox1. Now let's use the IP address of the BusyBox1. What's the IP address? 172.170.4. See what's happening? It is pingable. That means BusyBox2 container is successfully pinging the BusyBox1. This is the BusyBox1. This is BusyBox2. Okay. So the BusyBox1 IP address is BusyBox2 IP address is this one. And BusyBox1 is able to communicate with the BusyBox1 with its IP address, but not with the host name. Okay, container name is also called as host name, friends. Okay, or service name. So now BusyBox2 can ping BusyBox1 with the IP address, but not with the container name or the host name. Okay, so ping is happening. Now exit from it. Now control PQ. Now go inside BusyBox1. Message. We have to use -IT. Ping. It got struck, friends. Friends, can you hear me? Nikhil?
Yes, sir, you're audible.
Okay, 172.17.0.2. Okay, so those two are pinging each other with their IP addresses. And I will make a statement and I will conclude it. I will close the session today. So BusyBox2. Okay, it is saying bad address. Now, in this case, what is happening is by default, every container gets an internal IP address, and every container will be able to communicate with every other container with the IP addresses. By default, they will be able to communicate with each other through their IP addresses. How we have tested it? By using ping. So by using ping, we have tested that BusyBox2 is able to communicate with BusyBox1 with the IP address, and at the same time, BusyBox1 can ping BusyBox2 with the IP address, but not with the host names. But in the world of container, there is no significant to IP address. We always rely on host names. That means we always rely on the container names, but not the container IP addresses. How to achieve that? Tomorrow we will see. That's it for today, friends. Let's meet tomorrow. If you have any questions, you can ask me. Otherwise, we can wind up this session. Thank you.
Sir, actually, I didn't get this material. Can you please share it on the group?
These institute people, they have to create a Google Drive for us. Okay, and in that they will upload the videos and I will upload the notes, but they did not send me the Google Drive. I will ask them tomorrow, and by tomorrow's class I will upload the material in that. Okay,
Okay,
meanwhile
sir.
please do this using the videos.
Okay.
Thank you, friends. Bye.